So I'm just going to start to record a session, and the plan for today it's we're going to go through a very brief a reminder for anyone that is not at the moment probably connecting just because they saw the link in LinkedIn. I'm just going to remind what is the community status at the moment, and we're going to do some configuration in Git, and I will take the time to make sure that everyone is able to copy all the material that we will be using for the session today. We will have some very basic introduction to control flow statements just to warm up and start to work with some more advanced features of Python as we go forward in the exercise. And the plan is to end up with a couple of DCA exercises. The first one, it's on a single well. We are not going to use anything fancy, just native functionalities of Python on this one, for loops and control flow statements, as I mentioned before. But in the last part, we will be doing a DCA, a decline curve analysis with multiple wells that are in an Excel file, right? So just to carry on, I would like to ask if everyone is already up to speed with Git, and if they already have a GitHub account. This is important as we move forward in the sessions. Okay, could you please in the chat reply if you have a GitHub account and if you have Git installed in your machines. Okay, right. Okay, so we have some positive answers there, which is good. By the way, if anyone has a Slack open and you see that someone is struggle to get access to the session, please let me know, and I can admit them. I can admit them on the session if we have any troubles. Okay. Now I'm going to paste this link to the GitHub repository that we will be mostly using. It's Orca Hub. It's where we are sharing at the moment the reservoir engineering material balance library, and also where we are starting to build a vertical lift performance, or let's say a production system analysis a library. So we have 3 repositories at the moment. Let's go to the PEG library. I'm going to send the link here in the chat. So if you can go to that link, please. So if I show you what we have in that folder, we have a couple, or that repository, the PEG is a petroleum engineering and geosciences in Python, and we have a couple of folders in that repository. The first one, in order of intention or functionality, it's a foundation where we will be populating with some basic notebooks. And in fact, if you have some notebooks that you would like to share through the community, just let me know, and then we can review them and probably put them here. The idea is that these notebooks should have some element of petroleum engineering, but should show some basic functionalities of Python. And Adolfo also has been putting together some notebooks that maybe they are more generic. So those will be shared here. Hopefully, I'll have to check with Adolfo. The second folder in the repository, it's the second folder in the repository. It's a DCA folder, the DCA folder, we have some exercises that we will be working with today, and hopefully there are a couple of more sessions that we could do in DCA, or if declining curve analysis. If you have any suggestions, we could do some more, or if you have some material that you would like to share, we could do those. Okay. So the first thing that I would like to ask you to do, it's if you go to the repository, and let me see here. You should see when you go to the Git repository, you could see a link to clone the repository. Okay. You can also download the whole zip file. So if you don't have GitHub, you can still download everything through a zip file and unzip and continue working with the repository. Okay. So up to this point, anyone have a question? Anything that that you're missing from the repository? Can you see the link to clone the repository? Please reply on the chat if you're able to. If you are struggling, to see the repository, I will explain in a second how to clone it. Yes, the sessions are recorded. I'm recording in my machine. Anyone, it's welcome to record a session, just in case my recording software fails to record. Okay. So, did you all have access to the PEG Python repository? And can you see this link to clone the repository? Okay, one yes. You just need 5 yes. Okay, I'll share the link again. Just make sure that you see this link here. Okay, anyone struggling with it? No. Right, I'm going to carry on. And the first thing that I'm going to show you is how to clone a repository. You can use a command line or command prompt. I think that most of you should have a Git and a GitHub account, but you should have also Git installed. If you haven't got Git installed, you should go into Git. And depending on your operating system, you can download the version that it's applicable to Mac and Linux, I believe, and Windows. So you have all these options to download Git. So you need both a Git and GitHub. All right. So I have GitHub already installed in my machine. And what I'm going to do is open a PowerShell, or also you can open a command prompt. Going to try to maximize here the screen. Right. So I'm going to go to my drive M in this case, and I have a folder that I have called tech. I'm going to go into that folder, and the only thing that you need to do is git clone, and if you copy and paste that link, If you copy this link,
Sorry, Alejandro, I guess the screen cannot be seen.
you cannot see the screen.
Yes, some people in the chat is saying that I cannot see neither.
Hold on a second. Oh, hold on a second. What about now?
Yes, we can see that.
Yeah, it's visible.
Okay, I'm going to go one step back. The first thing that I was showing you, it's in Orca Hub. If you go to the code, you can see the option to clone the repository. So if you click on that icon, you can clone that repository. And what I was showing you in the PowerShell. Let me magnify here a bit. Right. So if you use a git clone command and paste that link, you will notice that everything will be downloaded. And if I go to that folder, so you will see the DCA folder and the foundation folder with all the material. Okay. Can you please let me know if you are able to see if you are able to download through, or if you're able to clone the repository or download the data?
I managed to clone it.
You managed to clone it, okay. Okay, downloaded the zip file. If you don't have if you're struggling with Git and the GitHub account, don't worry, you can still download the data, and later on we can work out, or you have to work out and make sure that you have Git installed and everything up and running. Awesome. Okay, some positive feedback. People already having being able to see to download the data. So I guess at this point, everyone it's up to speed with Jupyter. Am I correct? Do you have all your either your navigator, Anaconda navigator, and you are able to open in Jupyter, and or you probably open Jupyter itself? It's everyone up to speed with Jupyter? Okay, so then we're going to run through the first exercise, which is a control flow statements. Very simple, very small exercise, just illustrating some basic configuration or basic examples of Python commands. All right. So here we go. I'm going to open the control flow statement, and in the notebook, it's a basic illustration of if, else, and elif statements. Okay. So as we move forward, the first example is I have some condition and I want to run an algorithm. In this case, I want to assign the value of porosity of 0.15 to this variable and print if porosity is greater than 0.1, it's going to print sand, right? So very simple. I'm going to close the parentheses here. It's an error that was introduced on purpose, and there are a few errors introduced on purpose on the student one. So you have to figure out what's going on in some of those. But if I run this, you will see that it's printing sand. Now in this next case, porosity is equal to 0.05. So if porosity is greater than 0.1, it will print sand. But obviously, as you can see, the porosity is not greater than 0.1, and nothing is being printed. So if else, now let's say that we want to print what happens with the when the porosity is lower than 0.1, and so we have in this case if porosity is greater than 0.1, print sand, otherwise print shaly sand. And okay, so we have an issue here, and the error that was introduced on purpose on this particular notebook. And every time that you put a control flow statement like if, and else, and a for loop, you always need to have a column here. So now we have a shaly sand. Let's try with exactly 0.1. You probably need to cover the case where porosity is exactly 0.1. And in this case, because in this case it was just greater than 0.1, it printed shaly sand. But because we are covering the case where it's greater than or equal to 0.1, then we print sand here. This is just a brief reminder of control flow statements, and will be useful as we go into the DCA exercise, the first DCA exercise. Okay, let's go to the next one. Elif, if, and else. So in this case, we have two conditions. We have porosity and permeability. So whether porosity is greater than 0.1 and permeability both have to be, porosity have to be greater than 0.1 and permeability has to be lower than 1000, then we are pretty much printing sand. And else if porosity is greater than 0.1 and permeability greater or equal to 1000, we print a mega perm sand. Otherwise, we'll print a shell. Pretty simple classification. We give the values, porosity and permeability. And in this case, for the given values, we print we have a mega perm sand. Now, another way to look at this is instead of having the conditions, both conditions stated on every one of the lines, we can have nested conditions. So we say if porosity is greater than 0.1, then you have other conditions here. If permeability is greater than 100, it's shaly sand. If permeability is lower than 100, lower than 1000, and greater or equal than 1000. And obviously, in the control flow statement, everything will be tested in that order. So the first one is this one. If this condition is met, then it will immediately return the shaly sand, and it wouldn't test the rest. So what we are doing here is we test first for porosity, and then we test for permeability. So in the case of porosity equals to 0.15 and permeability equals to 1500, then obviously we are getting into the loop because porosity is greater than 0.1, and we are getting into the case where we have permeability greater or equal to 1000. So very simple classification example, and you can see how the loop, the control statement works for in a nested way. Okay, the next one is the print statement, or the for loop. In this case, we're going to make a counter for I, let's say, equal 1 or 0 to 5, and let's print. Actually, let's print this is I, and this is another small error introduced here. So what's printing here? So it will print all the values from 0 up to 4 in this particular case. It will it's because in Python it's a bit different than R. R will start, the counters in R start with in 1. The counters in Python start in 0. So you still have 5 items, 1, 2, 3, 4, 5 items, but they are all the counter starts from 0. Okay. And